Hello and good afternoon. CTS267 Section 840 students for the spring 2017 semester at Anne Arundel Community College. This is the CCNP TSHOOT course, and this afternoon's video tutorial is going to be a continuation into the SECHNIK Networking Limited Company's network troubleshooting process here. We're going to be again presented with a number of trouble tickets that we're going to have to resolve. The topology should look familiar, right? This is from Challenge 1, and we're actually doing Challenge 2 right now. So let's dive in here and see our first trouble ticket. So Kimberly, the user on PC1, cannot access the internet. Peter's unable to offer further explanation of this issue. And Peter's a co-worker, network engineer, and so there's some issues here. So again, can't stress this enough, follow the process, right? Follow your process. So here we are on PC1, and I already know the IP address that we need to try to get to, and that's the 209.165.201.225. So we're on the PC here, so let's go ahead and we're going to divide and conquer right away. So let's say 209.165.201.225. And let's see what happens when we go to ping here. All right, so we've got no connectivity right now, but again, if you look up here, it appears as if we did pick up a DHCP address. So let's see, show IP interface brief, and let's confirm that. So we did get a 192.168. So if I can't ping all the way out to the device I'm trying to reach, can I get to my default gateway, 192.168.10.1? And so I can, right? So now I'm going to kind of follow the path here. So I made it to the distribution layer switch. Let's check router 1. And let's see, show IP interface brief. Router 1 has a series of interfaces here. So can I get to that inside interface? Or, I'm sorry, the outside interface there, that 209.165.201, which is this interface right here. So can I reach that interface from this PC? So 209.165, and was it 201.1? 201. So 200.1. All right, so I can make it all the way to that interface without any issues. So the question then becomes, just like it was last time, well, we should probably take a look at that interface. So let's say show run interface Ethernet 01. We can see we've got that IP NAT outside. And so again, we see that NAT statement there, right? And that kind of indicates that, well, maybe we need to take a look at show run include NAT. And let's see how we're set up here, and let's make sure access list 21 is correct. So show access list 21. And it is permitting the right networks, right? So NAT, which was the issue last time, is definitely not the issue this time. So what happens if we try to ping from the router to the 209.165.201.225? What happens? So we've got no connectivity again. All right, well, if I don't have connectivity from my border router, let's go ahead and say show IP route 209.165.201.225. And so we can see here it's known via a static. So we have a static route with a distance of 1, right? That's the administrative distance of a static route. And what is the next hop that it points to? Well, it points to 172.16.100.2. So where is that address? Show IP interface brief. You can see we have this 172.16.101, which is our Ethernet 02. And that was Ethernet 02 right there. So what is the address here on this distribution layer switch? Yeah, so take a look. The IP address on the distro layer switch brings us to the 172.16.100.2. So in effect, what is happening here? Well, we're able to, I shouldn't say trace, we're able to ping all the way to this inside interface here, right? But we can't get over here, which is our 209.165.201.225. So we can't ping out there. And when we said show IP route for that IP address, what did we get? Well, we got an entry that said if you're trying to get to the 209.165.201.225, go this way. Well, that's a problem, right? Because the traffic is getting up to here to router 1 only to be told to come back down to the distribution layer switch. So how else could we see the effects of that, right? Where we have a static route pointing in the wrong direction. Well, let's come down here to PC1 and let's trace route, right? So let's say trace to the 209.165.201.225. And actually, let me Control-Shift-6 out of this if I can. There we go. Whoops. Sorry, I didn't mean for that to pop back up like that. All right, so I'm going to say numeric. And take a look at what's happening, right? It should be really easy to see what the issue is here. So as soon as I trace, I go to my default gateway for my first hop, which is what we would expect, 10.1. 10.1 takes me up to 172.16.101. And remember, 101 is the router, and then it sends me to the distribution layer switch. And then I go to the router, and then the distribution layer switch. Router, distribution layer, router, distribution layer. And as you can see, that continues. So what do we call this? Exactly. We have a layer 3 loop. If we were to take a look at the distribution layer switch, and I was to say just show IP route, take a look. Remember, we have an OSPF learned default gateway that says go to 172.16.101. And so basically, we're just ping-ponging back and forth here between the distribution layer gets the packet and says, I don't have a specific route, but I know my default is here. Router 1 says, I've got a specific route that says send it here. And then the distribution layer sends it here, and then this is what we've got going on, right? So we've got this layer 3 loop, right? We've got a layer 3 traffic loop here between the distribution layer switch and router 1. So how do we resolve the issue? Well, when you take a look at what's going on or where the problem really resides, it's the fact that router 1 is actually sending the traffic for an external network, this 209.165.201.225. It's actually sending that traffic back into our network. And so we're going to solve it on router 1 here. So do show run include route. So we should have a static route. And here it is for the 209.165.201.0. So for the /24 network, the next hop is 172.16.100.2. And we know that that shouldn't be the case. It should probably be 200.2. And if I were to ping that, that's going to be the address on the other side, right? That internet service provider, 209.165.200.2. And we can ping that address. So let's do this. Let's say no IP route, 209.165.201.0. It's a /24 that we're using for the subnet mask. And the next hop is not 172.16.100.2. Right, so that is not the next hop IP we want to use. We want to use IP route to get to the 209.165.201.0. That is a /24. The next hop should be 209.165.200.2. All right, so let's come back to PC1 now, and let's see, do we have takeoff here? All right, now that looks a lot better than what we had before, and it works fantastic, right? So can I ping out to the 209.165.201.225? Absolutely. All right, so that solved the problem. So the first problem was we had a bogus static route that had been put in there. And real quickly, just a comment. So I'm using this numeric. If I'm not using numeric when I do the trace route, what's happening is the reason that trace route always takes so long in real world situations and it doesn't do it right away is it's trying to resolve the IP to the host name. Right, so when I say numeric, I'm basically telling it don't try to do any DNS resolution, just simply use the IP addresses. And that's why when we do numeric like this, it happens so much quicker than when we don't, right? And I always like to use numeric because you don't want to have to sit there and wait for things to to go on and on and on. All right. So that was the first one. We've got a bad static route that's been taken care of. So ticket 1 is done. So we let Peter know it was a bogus static route. Now, trouble ticket number 2. Peter explained to you that he tried to configure a security feature where users only establish an SSH session to the server 172.16.210. Now, but nobody would be able to establish a session from the server. However, the feature is not functioning properly. Andrew, the user on PC2, cannot use SSH to connect to the server now. So this kind of gives us an idea that the problem is he put on some sort of a security feature, so it's maybe on the server, and my guess is we're probably looking at some kind of an ACL or something like that. So let's take a look. Let's dive in here and see when we say Andrew, the user on PC2. So let's see. Let's first check PC2, and let's see if PC2 has any connectivity up to the server. And let me reconfirm that server address should be 172.16.210. I think I wrote that down. 172. Yeah. All right, so we've got the address there. All right, so can I ping to the 172.16.200.10? Do I have reachability? Well, take a look at what's happening. We're getting the U period, and it's not working. So there's clearly some sort of an issue. What happens if I were to trace to the 172.16.200.10? Remember, we had a bogus, and I should have said numeric there. And there we go. And then we get this exclamation mark A in the trace route. Now, remember, in the trace route output, when you see that exclamation mark A, that is typically 99% of the time related to some sort of an ACL, right? That we've got some sort of an ACL blocking. We got the ping unreachable, right? The ping comes back unreachable, and the trace route is indicating that there's some sort of a permission denied. We've got an ACL in the way somewhere. So we know that he was making some sort of a security change. Let's get onto the server here and let's see if we can see anything. And the password I want to say is CISC0. There we go. All right, so on the server here, if I say show access list, let's see if we have any ACLs here. We do not. Let's do a quick show run. And there's the interface that we're trying to get to. Okay, it's got a good static route there, good default route out. Transport input SSH, right, which is what we're trying to do. So, but nothing here. So now I'm going to take one step back. I'm going to come over here to the router. And we're going to say do show access list. And let's see what kind of access lists we have. And so we can see here we've got the access list 21, but we know what that's being used for, right? That was being used for our NAT. And then we see we've got this access list 111, permitting TCP from the 192.168 to host 172.16.200.10, and it's established. So let's see, is this applied to any of our interfaces? So I could say do show IP interface brief, and let's see, do show run interface Ethernet 00. And there we go. So this is the interface that faces, or it's the link, the direct link to the server, right? And the IP address for us is 172.16.201. And here we go. IP access group 111 outbound. So it's applied to this interface here, and let me confirm that. Let's make sure that's the case. Take a look at the job. So that's Ethernet 00. So remember, 02 points toward the distribution layer, 01 to the internet, and 00 is the link over to that server. So we've identified that we've got an ACL, and it's permitting TCP to the 192.168.00 from that host. The connectivity established means that once the TCP session is established, that all traffic is allowed to transit, right? But it's in the outbound direction. So what we have here is we've got a problem with directionality, right? And again, what I mean by that is we take a look at the ACL and it says permit TCP traffic from the 198 to the 172.16.210. Now, this logic is correct because we want to allow SSH, which uses TCP. We want to allow it from the 192.168. And actually, are we dealing with... Hold on one second. Let me double check our... Where is the... I think it's PC2, so we may even be in the wrong subnet. Yeah, PC2 can't use SSH, and PC2 is in VLAN 20. So if we take a look at PC2, I'm glad I stopped there. So it looks like we've got multiple issues here. Show IP interface brief. And actually, no. PC2 is the 192.168.20. All right, so back to router 1. So we're allowing this traffic from 192.168.00 to the 172.16.210, but we're applying it in the outbound direction. And so what's the problem there? And actually, let's take a look at the statement. Is if we're going to say it's in the outbound direction, right, that's sort of a problem. Is that we want to have the ACL configured in the inbound direction, and we want it to be from 172.16.210, and that's why we use that established keyword, is that the traffic is allowed, or the TCP connection is allowed to be established, and then as long as it's established, the return traffic is going to be allowed. So what do we need to do here on router 1? Well, we've got a couple things that we're going to have to fix. So the first thing is we're going to say IP access list extended 111, and we're going to say no 10, which would be that first statement right there, right? So we're not allowing traffic outbound from 192.168. We're going to allow it inbound because remember, and let me be a little more clear on the requirement. We have to go back. I always have to go back and look at these things a few times. So it says, Peter explained that he tried to configure a security feature where users could only establish an SSH session to the server, but nobody would be able to establish a session from the server, right? And so this is actually a very good use case, right? So again, remember, you can only establish a session to the server, but not from the server. And this, the way it's set up, this allows the establishment from the 192.168, but it doesn't meet the second criteria because, again, we're applying this in the outbound direction. What we're saying is nobody can establish an SSH session from the server. So what do we want to do here? We want to say permit, whoops, let's get this back on. There we go. So we want to say permit TCP host, and again, permit it going to some other network other than the 192.168. So I'm going to say permit TCP host, and what's the server IP? 172.16.200.10, right? So permit TCP traffic from, whoops, from the 172.16.210 to the 192.168.0.0. We're going to do the whole /16, wildcard mask of 00255, and then established. And that's that key word right there, is that it's saying that as long as the connection is established from the 192.168, then the TCP traffic will continue to flow between this host and the hosts on 192.168. But we're not going to allow connectivity to any other subnets. So what we need to do for that is we need to go to Ethernet 00, and we need to say no IP access group 111 out, right? Because again, when we're doing the ACL and we're applying it as an access group to that interface right there, and the requirement is that only sessions can be established from the 192.168s, and other than that, nobody can establish a connection from the server going to any other network. And let's take one last look at that, right? So Peter explained that he tried to configure a security feature where users could only establish an SSH connection session to the server, but nobody would be able to establish a session from the server. And so we're going to apply the access list on this interface in the inbound direction, because we're saying that, yeah, if it's established, that's fine. That traffic is going to flow fine. But we only want to allow that traffic to flow if it's coming from 172.16.210 going to the 192.168s, right? We don't want anybody else to be allowed to send traffic there. So we're going to say IP access group 111 inbound, right? So we're going to apply the ACL inbound. So if I were to say do show IP access list extended 111, what did I miss there? Show access list. Oh, okay, I just want to see ACL number. Show ACL 111 established. So there we go. So there's our ACL. Now we've applied it, so let's come back to PC2 and let's run those tests again. So can PC2 even ping up to the server, 172.16.200.10? So I can't ping yet, right? So we've looked at, we know it was some sort of security work that was done. So maybe we've got another issue of some kind here from PC2. What if we try to trace? So let's trace numeric again, back up there. And let's see how far we get. So we get to the 172.16.101, right? And we know that's the distribution layer switch. And then connectivity dies out. So let's say Control-Shift-6. So I can't get to where I'm trying to go. So even if I were to say SSH -L CCNP to the 172.16.200.10. Aha! So can I SSH? Exactly. C1SCO. And I am on the server. So let me ask you this. Why did the trace route and the ping not work? Exactly. Because we have an ACL on the return interface, on router 1's interface in the inbound direction. So the ICMP echo replies, those are not being allowed through. What are we allowing through? We're only allowing through TCP from 172.16.210 to that 192.168 subnet. And so this is why when we try to ping or we try to trace route, that ICMP traffic is not being allowed back through. So how could we, if we wanted to be able to ping and trace route, what would we need to do? Well, we'd get into global config, we'd say IP access list, and so we'll go a little outside the box here, extended 111, and I would say 20, which is going to be the order of the access list. 10 allows the TCP traffic to come back through. I could say 20 permit, and we're going to say ICMP, and we're going to permit it, I guess we could just go, we'll do, say, any, and we'll even log it. All right, so permit ICMP any log. Come back to PC2. Let's get off of the server here, and let's see. And again, that recognition that, hey, we changed the ACL, and the only thing that we allowed was the TCP connectivity. And remember, ping ICMP is not using TCP, right? Now take a look. Now the trace route works beautifully. And what about the ping, which is also using ICMP? I think I have that state cached in here. And there we go, right? So it was that ACL that we applied that was actually breaking the ping and the trace route because we weren't allowing the return ICMP packets to come back. So again, this probably isn't part of the solution, but we definitely want to talk about it to make sure that we understand that applying that ACL in the return or the inbound direction on router 1's Ethernet 00 interface, if we don't allow other traffic to come back, what we're saying with that established keyword is, yeah, the outbound traffic is going to be an SSH connection, and as long as it's established, I'm going to allow the return TCP traffic for SSH to come back through, and the 192.168s are going to be able to communicate with SSH, no worries. And we saw that here from PC2. However, a side effect of that ACL is we kind of get this false sense that, hey, something else is wrong. But there aren't any other faults that we're looking at. It's just simply that the ACL that we applied was restrictive enough that it's not allowing the ICMP reply return traffic. All right, so let's, I think that's it for that ticket, actually. Let's take a look here. So Peter explained that he tried to configure security features or user could only establish. Yep, the feature's not functioning properly. Okay, good. All right, so trouble ticket 2 is down. Trouble ticket 3, Peter also configured port security on the access layer switches. However, Mithun, the user on PC4, does not get an IP address assigned via DHCP. Well, they're telling us, right? And again, so would this be divide and would this be divide and conquer? Would we need to do a ping here? Not really, because they're telling us that he configured port security and now PC4 can't get an IP address. So we kind of, and this might be the shoot from the hip, is that, oh, okay, well, if he configured port security, then that means that something must be wrong with the port security configuration. So this would be sort of an assumption that we're making with Mithun's PC that Peter applied port security on the access layer switch, and it's got to be done incorrectly. So that would be where we could start. So we take a look at the diagram. So let's get PC4 up here. This is Mithun's PC, and let's get into privilege exec. Let's pull the diagram back up, and let's get this access layer switch up here. All right, and let's see what we've got going on. So show interface status, and I left off the IP interface status so that we get the right output here. So we can see Ethernet 01 and 02 are PC 3 and 4 respectively. So let's do a quick compare and contrast. Show run in Ethernet 01. And so I don't see port security on here, right? For PC3. Let's check for Mithun's PC. So how about a show run interface Ethernet 02? All right, it doesn't look as if port security has been applied here either. So let's do show port security and let's see what might be going on. All right, so fantastic. So it looks as if the issue isn't specifically on the host ports. It looks like the issue is on Ethernet 00, which, if I'm not mistaken, that goes up to the distro layer switch. Yeah, link to DSW1, and you can see right there it's air disabled, and it's a trunk. So we've applied port security. It looks like they're putting port security on the trunk, and you can see here that the default action that's going to be taken is shutdown. So it looks like we've got the default action. So let's see what the trunk looks like. Show run interface Ethernet 00. And you can put port security on your trunk interfaces. However, there's a lot of MAC addresses that are going to be transiting or that could be learned across those trunk interfaces. So not recommended to put port security on the trunk links. More of an access layer access or host port facing feature. So what do we have here? So we're good with the switch port trunk allowed. The encap is .1Q. That looks good. We see switch port mode trunk, port security, and port security for the MAC address. And it looks like they've got this MAC address in here, which I can almost guarantee does not correspond to anything So we've got switch port security, MAC address 0000. So what might be the problem? So let's say show MAC address table. So those are the MACs that we've learned dynamically. However, they have hard-coded this, and again, the defaults play a very important role here. Another command that we could use would be show interface switch port, and I think that would be good enough because we're going to see Ethernet 00 first. So we see the interface here, right? Trunk mode, the operational mode is down because it's air disabled. And you look at the private VLAN information, we're good on the trunk length, so everything looks good from this perspective, but we know that the trunk is air disabled. But that MAC address, that's a completely bogus MAC address. So let's sort this out. Let's first go ahead and get into interface Ethernet 00, and we're going to say no switch port security. So do show run interface Ethernet 00. So we pulled the port security off, and so let's say no switch port security, MAC address 1234, 1234, 1234. Right? Because the defaults play an important part here. The first default that's going to get us is going to be the maximum. So if I was to say switch port security maximum, that's how many MAC addresses could be allowed, right? And if I don't say anything, the default is 1. And so this is the only MAC address that's going to be allowed. In order to allow additional MAC addresses, I would have to increase the maximum. So that might be one approach that we could take. However, that's not what we want to do because the port security feature should be on the ports facing the host machines. In other words, PC3 and PC4, not on the trunk link. So we've totally taken port security off the trunk link. So, but we still have do show interface status. So we still have this air disabled trunk link. Well, there is no air disable auto recovery, right? That's not turned on. If it was, we should be seeing some sort of a message. So let's say do show run, and let's see include air disable. So that's not on. So we're going to have to shut the interface down. And then in order to bring the interface back up, we need to say no shut. So we've now pulled that port security feature off the trunk link. Let's say do show interface status. All right, so now we're connected. Do show interface trunk. What does our trunk look like? Well, we see the VLANs in the spanning tree forwarding state, so we're probably waiting for spanning tree to do its thing here. And so we should see that last line. This last line is always probably one of the most important lines. Is it should not say none. If it says none, that means that no VLANs are being sent over that trunk link. And we know that that is not what we want. That is what we want. So we just give spanning tree some time to reconverge, and there we go. VLANs allowed 1, 10, and 20. So that was one thing that we got sorted out. Let's see here on the last ticket. Port security on the access layers, however, now Methune on UZPC. So PC4 could not get an IP address. So now let's come back to PC4 and say show IP interface brief. Did this fix it? Well, let's get into interface Ethernet 00. We're going to say shut, and then we're going to say no shut, but we're going to wait for it to report that the interface is down and the line protocol is down. And then we say no shut, right, in the hopes that we're going to generate a DHCP discover request, that broadcast that sources from quad zeros because we don't have an IP yet, and is a broadcast of the all 255s. And we're looking for a DHCP server, and now show IP interface brief. We've got what we were looking for. So, not Methune, but Peter misconfigured port security. So how would we configure the port security? Well, let's say do show MAC address table. Whoops, sorry. Thought I was on the access switch there. All right, so we're on the access layer switch. Do show MAC address table. Right, so here we go, coming in on Ethernet 01. This is PC3. and this is PC4. So now there's a couple ways that we can sort this out and fix this, right? So let's do this. Ethernet 01. We're going to say switch port security. Switch port security maximum is 1. That's the default. So it wouldn't matter if I type that in. In fact, if I put that in, we're not going to see that in the config because it's the default. Switch port security violation shutdown. Same thing. That's the default. So when I say do show run interface Ethernet 01, we don't see those two options, right? There is no violation shutdown and there is no maximum 1, right? But what we do need is switch port security and MAC address. Now we've got some options here. We could hard code the MAC in here, or I could just simply say sticky. And what's going to happen is it's going to learn the MAC address off of the first frame it receives inbound. It's going to learn that source MAC, and that's the MAC that it's going to attach here. Do show run interface Ethernet 01. And there we go. And was that the right MAC address? Do show MAC address table. Ethernet 01, that's PC3, AABB, CC00, 6700. Perfect. So 6800 is going to be PC4. So we're set there. So now we'll say interface Ethernet 02. And I could have interface ranged this and done it for both at the same time, but we'll do them one at a time. It's not a big deal. So, whoops, switch port security. And remember, we have to have that command by itself on the interface. It needs to be there, or else all the other commands aren't going to take effect. So switch port security, I don't need to do maximum. I don't need to do violation because they're already set. So we'll say MAC sticky. And in fact, let's do this. We'll do this one differently. I'll say MAC, and we know that it's going to be AABB.CC00.6800. Right? And was that not... Oh, did it already do show run interface Ethernet 02? I am in Ethernet 02, correct? Found duplicate MAC address. Interesting. So that MAC should only show, and it does only show on that one port. Did I type that right? CC006800. All right, so let's see what happens if we say sticky, because it should take that. So it took the sticky, do show run interface Ethernet 02. Whoops. And there it is. So, okay. We had to get that MAC address sticky in there to get that to work. And I believe that should be it on this side. So do show port security. So there we go. We've got port security on. What is the action? The action is going to be to shut down. Security violation count is 0. We haven't had any issues here. Current address MAC address count is 1 on each port. And what's the max security address count? 1 on each port. So again, by looking at this, we can quickly see that, hey, I didn't set these things, but these are my defaults, right? Shutdown and max secure address count for these two host-facing interfaces. All right, now, it's possible that they want us to go over to the access layer 1 switch and do something, but if it is, I'll leave that to you guys to go ahead and do the configuration for the port security on access layer switch 1. And so now that PC4, Methune's PC has an IP address, can we ping out to the 209.165.200.2? And we can, right? So everything works fantastic. All right, so again, following the process based off the information that we've received becomes very, very important, right? And being able to look at the description that you're given and determine, okay, well, it says he put some security feature so that the server could, you can't SSH from the server, but you can SSH to the server. We're able to sort of quickly move to those devices and take a look to see what's going on. And again, when we're faced with issues where, hey, it's not getting a DHCP address, oftentimes the best way to approach that is from the bottom up. All right, thanks for watching, guys, and I'll see you on Thursday night.